Hi everyone, I welcome you all in this fourth video where I am teaching you how you can find the range for any given functions in your AS level. In the last class, we talked about that if any kind of a straight line is given to you along with its domain, how easily utilizing its y-intercept and the x-intercept, you can connect them and draw a graph very quickly. And after that, based upon the domain, whatever is the domain, you highlight the region of interest and mark your minimum and maximum values. And based upon that, you write your final answer for the range. Now, there are three different techniques in which you can express your range, and all of that I have explained in the second video of this playlist. So I hope that you have watched the previous videos of this entire playlist. Only then things will make a lot of sense in this video where I'll be explaining how you can find the range for any given quadratic functions, and then later on with the help of Desmos how you can practice it by yourself. So yes, let's get started. So the first thing we'll discuss about is how we can draw the quadratic graphs very quickly. For that, you need to know these three things from the given quadratic expression or the function. The first thing is to identify if your quadratic graph is going to look like a U shape or an inverted U shape. This is how exactly your graph is going to look like. How do you know this? By looking at the coefficient of the x square. If that is positive, it's a U shape. If it's negative, it is an inverted U shape. The second thing is to identify your y-intercept. How do you find this? By letting your x is equal to 0 and then whatever is the output of the function, that becomes your y-intercept. And the last thing is your vertex or the turning point. Your turning point is this one for the U shape and this one for the inverted U shape. So what is the x and y coordinates of that particular location? So there are two different techniques you can utilize to quickly find the coordinates of this vertex. If your quadratic function is given to you in the completing square format, you can directly use minus of this value, that is minus b in this case, and write this value as it is, that is c in this case. Let's say if I'm giving you 2 times x minus 3 the whole square plus 7, what is the vertex coordinate? It is simply going to be minus of this, which is minus minus is positive 3, and the y value is plus 7. That becomes the vertex for this particular completed square format of this quadratic function. But now let's say if a completing square is not given to you. By the way, if you are given to find the range, this is what you can expect in almost all the questions. But let's say in some of the questions they give you this standard way in which we write the quadratic expression, that is ax square plus bx plus c. What is the fastest way in which you can find the vertex point? So the fastest way is the x coordinate of the vertex is simply minus b by 2a. You do minus b, divide that by the 2 times the value of a. Once you're having the x value, of course you can substitute that as an input to this function and it is going to give you the y value of this vertex. So for an example, let's say I'm having x square minus 3x plus 7. In this case, what is my x value of the vertex? It is minus b, that is 3, divided by 2a, that is 2. So 3 by 2 becomes my x value of the vertex. How do you find the y value? Just put 3 by 2 in your calculator, and in this case if I'm going to put 3 by 2 in my calculator for x, it is going to give me the output. Let me check. It is going to give me the output of 19 by 4. So yes, that is how you can quickly find the vertex. So if you are having these three things, you are going to draw your graph within 10 seconds. And after that, based upon the domain, you can highlight the region of interest and then finally find your range. I hope that the idea on how to quickly draw the quadratic graph is clear. And of course, once I show the examples, it will become even clearer to you. And now just like the straight line functions, I'll come up with the random equations and the random domain. For the practice purpose, I'll show you how you can create the graphs, and then utilizing the Desmos, we'll also go ahead and check our answers. So yes, the first question that we're going to deal with is find the range for f of x is equals to 2 times x plus 1 the whole square plus 2 for x greater than equal to minus 1, or maybe x greater than equal to minus 8, let's say. Okay, this is the question that I have found by myself. And how to draw the graph? The first thing you need to know is what is the coefficient of the x square. As there is a positive outside, it means that the coefficient of x square is positive. So 100% it's a U-shaped curve. The second thing is the y-intercept. No, it's not this 2. Okay, how do you find the y-intercept? Put your x is equal to 0. Okay, so 2 times 1 square is 2. 2 plus 2 is 4. So y-intercept is equal to 4. Okay, it's a U-shaped parabola with the y-intercept being at 4. What is the vertex point? It is at minus of this value, comma this value. So minus 1 comma 2 becomes your vertex point. So given that you are aware about this, let me write all of these things over here. It's a U-shaped parabola. The y-intercept is 4 and vertex point is minus 1 comma 2. Now let me create a quick axis. I'll mark certain points on my graph. 4 is maybe somewhere over here. My minus 1 is over here, 2 is over here. So of course this is my vertex point. And if I have to sketch my graph, it's a U-shaped parabola which is going to look something like this. And that's how easily you can sketch your quadratic functions. It looks very difficult to draw for me over here, but yeah, we just did a rough idea. And of course the arrows pointing upwards, showing that my graph can keep on going upwards if it has to. Now if I look at the domain is everything to the right side of minus 8. Let's say minus 8 is somewhere over here. Put minus 8 as an input to get the respective output, but to be honest, it's not required over here for this particular question. Why? I'll show you. Because this is the region of the interest, everything to the right side. What is the minimum value? What is the minimum output you can see in the graph? Clearly, this is the minimum point. This is the minimum. And of course, this is maximum, which is going forever till infinity. So the minimum value of the output is 2 and the maximum value is infinity. So everything should be greater than or equal to 2. Why equal to 2? Because the 2 is the output when x value is minus 1. Is minus 1 part of your domain? Yes, minus 1 is indeed part of this domain. As you can see, it's coming under this yellow graph. And therefore, 2 will also be part of the range. So how will I write my answer? I'll say that f of x is going to be always greater than or equal to 2. And here this becomes our final answer. You can also cross check the answer using your Desmos. The question was 2 times x plus 1 square plus 2 and the domain was x greater than equal to minus 8. And if I can show you the graph, so yeah, at minus 8, of course, the output is some value. We don't care about that, to be honest, because the least value your graph is giving you, the least output your graph is giving you is 2. And the maximum value that your graph is giving you, everything you can see is going above and above because, of course, it is pointing towards infinity. And that is exactly what we have depicted in the graph over here. And now because everything is in front of you, clearly we can see that your output values for this graph, the minimum value is 2 and the maximum value is infinity plus infinity. So everything greater than 2 will be part of your answer. Once again, why 2 is included? Because minus 1 was part of your domain, so 2 will be part of your range. So here was my first question for you. Just like that, I'll create a second question. And this time, let's try to put a negative sign outside. So find the range for function let's say minus x minus 1 whole square plus 1 for x greater than equal to 3. Let's say this is the kind of question that I have created right now for us. So because I am having a negative side, of course when I open it, x square will get multiplied with this negative sign. So this time my graph is going to have inverted U shape. What is my y-intercept? When my x is equal to 0, I will have minus of 1 plus 1. So minus 1 plus 1 of course is 0. So you will say that your y-intercept is 0. And then what is the vertex point? The vertex point, as we can see, is negative of this value comma this value. So 1 comma 1 becomes your vertex. So just like the previous question, I have written this down so that I know what kind of things I need to plot. So this is my rough plot where I need to mark my y-intercept of 0, 1 comma 1. This is my 1, this is my 1. So this has to be my vertex point. So my graph is supposed to look something like this. Of course, it's an inverted U shape. It's going to look something like this. Now, the domain is x greater than equal to 3. So I'm not sure if 3 will come over here or over here. So yeah, for that, let me put the 3 in this equation. So minus of 3 minus 1 is 2, 2 square is 4. So minus 4 plus 1, of course this will come out to be minus 3. So your 3 has to be somewhere over here, let's say. So this point could be your minus 3 on the y-axis. Now, as the domain goes everything to the right side of 3, the outputs that you're going to look into for this graph is this. So this yellow part becomes the area of your interest, where the maximum value of this output, as you can see, is minus 3. This is your maximum value. And of course, the minimum value is going till negative infinity. So in this case, how are you going to express your range? You're going to say that your output values are always going to be less than or equal to minus 3. Right? Why we are including minus 3? Because you got minus 3 when x was equal to 3, and x equal to 3 is part of domain. So minus 3 will also be part of your range. So that becomes our answer. And if I have to cross check it, I'll go to the Desmos, and it is minus x minus 1 plus 1, and domain is greater than equal to 3. And if I come to this equation, to this graph, you can see that the graph is starting from minus 3, right? Minus 3 is the starting value. And from minus 3, you can see that everything below that can be accepted. So your outputs can be anything that is either equal to minus 3 or anything below that. And therefore we confirm that the answer that we have written is 100% correct. Now, let me give you two more questions, and this time we are going to deal with the standard way of writing the quadratic expression or the function. So let me write, find the range for f of x to be anything, let's say 2x square minus 4x plus 3, and for the domain, let's say minus 1 less than x less than 5, something like this is the domain that I have chosen randomly. So in this case, what is the sign of the x square coefficient? It's positive, so we know that it's a u-shaped curve. What is the y-intercept? In this case, if you put x equal to 0, 3 will be your y-intercept. What is the vertex point? How do you find it? You do minus b divided by 2 times this value. So minus of minus 4 is 4, divided with 2 times 2 is also 4. So your x value of the vertex is 1. How do you find the y value? Put 1 in this equation and get the respective output that becomes the y value. So 2 times 1 is 2, minus 4 times 1 is minus 4, plus 3. So 2 minus 4 is minus 2, minus 2 plus 3 is plus 1. So 1 comma 1 becomes your vertex in this case also. Now I am going to go ahead and create a quick sketch. Everything is ready in front of us, all the three things. So 3 may be somewhere over here. Maybe 1 is over here, 1 is over here, which is your vertex point. And it's a U-shaped curve. So it's going to look something like this. So yeah, that is how quickly you can draw your quadratic graph. And now, because your domain is lying in between -1 and 5, remember 5 is not included, -1 is included. Okay, so let's go ahead and find out the respective outputs at -1 and 5. So at -1, if I use my CAIE directly, so in my CAIE I am typing this, of course you can do it along with me in your CAIE, 2 times -1 square minus 4 times -1 plus 3, and that answer comes out to be 9. And if I do it for the 5, so in place of -1 in my CAIE, I'll just substitute that with 5. And the answer that I'm getting now is 33. So clearly, out of 9 and 33, which one is largest? 33. So I'll just mark on my graph where my 5 might be present and the respective value may be 33 over here. And -1, of course, 9 can be somewhere else, but we don't care because clearly this has to be the minimum value. So let's say you are plotting -1 somewhere over here. So the region of interest is from this part all the way up to this part, right? From this part all the way up to this part. In this region of interest, clearly which is the minimum value? Your 1, this is your minimum value. This is your minimum. What is the maximum value? This is your maximum. This point is your maximum. So all the outputs will 100% lie in between 1 and 33. So how do you write your range? You're going to say that your f of x lies between the minimum value of 1 and the maximum value of 33 and write less than less than. Now is 1 part of your range? Yes, because 1 is part of your domain, 1 includes in this domain, so 1 will be included for your range also, the respective output. What about 33? 33 cannot be included because it was the output when x was 5, and because 5 is not part of the domain, 33 will not be part of your range. I'll just write this answer a bit on the top. So your output values are going to lie between these specific values. You can go ahead on the Desmos and try to plot this to confirm it. So 2x square minus 4x plus 3. Of course, if you are dealing with the past paper questions, you are having marking scheme to confirm. But during your practice, as you are creating your questions by yourself, domains by yourself, of course, there should be some kind of a validation. That is why I'm showing you how you can do that. So -1 to 5 is the domain. And the graph that you are going to get, let me just go down, 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 down. Let me zoom out. Okay, there is the graph as you can see, right? The minimum value of the graph is starting from 1. Of course, everything else is going to be part of the output until and unless you're going to reach to a value of, there is a 33 over here if I can show it to you, zoom in. As you can see, the y value is over here, 33. Okay. So yeah, our answer that we have written over here is 100% correct. So this becomes your final solution for this question. Let me create one more question. Find the range for f of x is equals to minus x square minus 4x plus 1 for x less than equal to, let's say, minus 1. Now the same thing, is it a U shape or an inverted U shape? Because the coefficient is negative, it's an inverted U shape. The y-intercept is plus 1. If you put x equal to 0, you get output as plus 1. And the vertex coordinate, how do you find it? Minus of minus 4, that is minus b, divided by 2 times a. So that is going to come out as 4 divided by 2. Sorry, 4 divided by minus 2. So 4 divided by minus 2 is minus 2. So minus 2 becomes your x coordinate of the vertex. Now put minus 2 in this equation. I'm going to use my calc for that. So minus 2 square minus 4 times minus 2 plus 1 comes out to be 5. So minus 2 comma 5 becomes your vertex. Now everything is ready in front of you. Sketch the graph. It's an inverted U shape. Your y-intercept is 1. The vertex point is minus 2 comma 5. This is your vertex. And because it's an inverted U shape, that is how it's going to look like. Okay, of course, this is your y-intercept. And now the domain is x less than equal to minus 1. So where is my minus 1? My minus 1 is of course somewhere over here. So my minus 1 will give me output over here. And if I sketch my graph or the region of interest, if I highlight that, that is what I'm looking into. What is the minimum value? Clearly, the minimum value could be as low as possible in the region of interest. It can go till minus infinity. I'm just focusing on this arrow. And then what is the maximum value? This is not the maximum value. This is the maximum value, which corresponds to the value of 5. So that is your maximum value. This is your minimum value. So how do you write your range? Your range is everything, every y value or the output value that is always going to be less than 5. Will I write this equal to sign or will I not write it? I will write it because I got that 5 at minus 2. And minus 2 of course belongs to the domain. So 5 belongs to the range. Hence, this is your answer. So yes, let's go ahead and check it under the Desmos. Minus x square, then minus 4x plus 1 for x less than equal to x less than equal to minus 1. Let's see how the graph looks like. So yes, as we see, 5 is the maximum value of the graph in terms of output, and the minimum value, it can keep on going down forever. So your outputs can be anything between the 5 to the negative infinity, and the way that we write this is in this format, as we have discussed about this in the second video of our playlist. So I hope even this is clear to you. So with this being said, we are done with this video where I have showed you how to create quick sketches of the quadratic functions. Along with that, how you can mark the region of interest, minimum and the maximum values, and then based upon that, how you can write your final value of the range or the final whatever you call this expression or the notation for the range. So yes, that's it for this video. In the next video, I'll talk about square root functions. Okay, so yeah, I'll see you over there. Thank you so much.